The distant world of Triton is full of mysteries and surprises. From a single flyby in 1989, we have been able to deduce a great deal about this large moon. But what are its mysteries? What are its surprises? And how many more questions do we have to answer? Triton was discovered on the 10th of October 1846, a mere 3 weeks after the discovery of Neptune, by the British astronomer William Lassell, who noticed that Neptune had a companion orbiting around it, and it was named Triton to fit with the theme of sea gods. So Triton orbits around 355,000 kilometres from Neptune in a very circular orbit, one of the most circular orbits in the solar system, and it takes around about just under 6 days for it to orbit around Neptune once. Triton's mass is about 0.4% that of Earth's, which is about a third of the Moon's mass, and its diameter is around about 2,700 kilometers, which is bigger than Pluto and not that much smaller than our own Moon. So the mass and the volume of the Moon are then put into an equation to work out the density, and the density works out as about 2.06 grams per centimeter cubed, and that's relatively high for a moon supposedly made entirely of ice. At first sight, Triton just looks like one of the other moons that are just entirely made of water ice. But in fact, the main ingredient on Triton's surface is nitrogen ice. Solid nitrogen ice. It's so cold here on Triton, about minus 235 degrees Celsius, not very far above absolute zero. And that is enough to freeze nitrogen, the stuff that makes up nearly 80% of the air we breathe. Is pretty much all frozen solid. Now the keen-eyed viewers amongst you all will have noticed that when I was showing the orbit graphics of Triton around Neptune, you will have noticed that it orbited in the opposite direction to the rest of the moons, which you can clearly see here. Triton is moving around Neptune clockwise, whilst all the other moons are going around anti-clockwise. And this is strange because it's a fundamental property of nature that once things are spinning, they will continue to spin, and they will continue to spin in the same direction unless something happens. So Neptune, when it formed, was spinning anti-clockwise because all the other moons that are closer to it are orbiting in that same anti-clockwise direction. But Triton doesn't follow this. This means that Triton and Neptune cannot have formed at the same place at the same time. For such a large moon to have such an unusual orbit, something very violent must have happened in the past. Now I mentioned that Triton was mostly made of nitrogen ice, which is actually very similar to what we see in objects in the Kuiper belt like Pluto. So does that maybe imply that Triton and Pluto formed in the same region? And there is a lot of support for this theory, because we believe in the past Neptune ploughed through the Kuiper belt, caused a late heavy bombardment, and that's why we see so many craters across the solar system from around about the same time period. The running theory is that while Neptune was ploughing through the Kuiper belt, it picked up Triton along the way, and Triton became a visitor to the Neptunian system, and by the laws of physics, it was forced to stay. Now there is more to Triton than just its strange orbit. Voyager 2 in 1989 discovered that there were geysers erupting from the surface of this frozen world. Nobody expected a world on the outer edges of the solar system would have geological activity. This moon is so cold and so distant. How could it possibly have geological activity? Also, this theory that Triton was captured by Neptune's gravity would maybe support this, because when Triton was first captured by Neptune, it would have been in a really elliptical orbit. At one point in its orbit it would be really close, and then it would be far away. So what happened is that over time, Triton lost its orbital energy, therefore became more circular. But while this orbit was elliptical, Triton would have been undergoing so much gravitational stress that it would have probably ripped bits off the moon and caused many geyser-like eruptions, probably so many more eruptions than we see now. And now, in Triton's state, being in such a circular orbit provokes a little bit more thought into how these geysers are still erupting. Because if it was slightly an elliptical orbit, then we could infer, okay, they're caused by gravity. But Triton's orbit is very close to circular, so where is the energy coming from to power these geysers? It might just still be gravity. Maybe there just is a weak gravitational difference around its orbit, and that's what's causing these eruptions. And you can see these eruptions from space. From these graphics in Space Engine, this is based off real imagery taken by the Voyager 2 spacecraft, and these sort of black smudges that you can see over Triton's surface are actually caused by geyser eruptions, cryovolcanism, cold volcanoes, pretty much. And these eruptions can be very tall thanks to Triton's weak gravity. They can rise up to 8 kilometres above the surface, and the fact that there's this many of them, you can see the streaks painted by these geysers, has led to the formation of a thin atmosphere around the moon. From these graphics, you may have seen this atmosphere already. It's about 0.00016% the pressure of Earth's atmosphere. It's a thin nitrogen atmosphere, but Voyager 2 has been able to observe that Triton does have some weather. There are clouds in Triton's atmosphere, albeit very thin ones. But it's interesting that any world with even a remotely thin atmosphere can have some form of weather. Triton being a captured object would also explain several other things about the Neptunian system. Triton is the only large moon in the Neptunian system, which is unusual because every other gas giant in the solar system has a system of large moons, whereas Neptune does not. And so the fact that Triton is a captured object would support the theory that when Triton got captured, it would have completely disrupted the orbits of the would-be moons around Neptune, and maybe even thrown them off or even destroyed them. And maybe that's why the moons closer to Neptune are small, and Triton is the standout member of them all, because upon Triton's arrival, chaos must have ensued. Now, the geysers on Triton have prompted some more thought about whether an ocean maybe exists under the surface, if there's maybe stored heat within the moon, and whether that's enough to warm an ocean. We've seen on several bodies in the solar system that you can have an ocean underneath a thick layer of ice. And if so, if that does prove to be the case, does that mean that even life exists on Triton? Its high-ish density may have huge implications for that prospect, because a higher density means that there is a different material underneath the ice we see on the surface. So that implies that there could be rock underneath the surface. And if there is an ocean, and if that rock is in contact with that ocean, is it likely that we would maybe even see hydrothermal vent systems? Now, hydrothermal vent systems are thought to be the cradle of life on Earth, the place where it all started for life on this planet. And so if Triton does turn out to be a water world, then we may seriously have to consider this place as a moon where life could exist. Now, as said before, Voyager 2 is the only spacecraft to have ever visited Triton in August of 1989. There have been several proposals for a Neptune orbiter in the future. That would be super cool. A mission recently was proposed for NASA's Discovery program called Triton, and unfortunately it didn't get approved for that lot of missions, but it's still a proposal that NASA could consider in the future. Basically, Trident is a mission that would do a single flyby of the Neptunian system and mainly study Triton. But hopefully in the future we can go and visit this place again with our spacecraft and explore more of the mysteries and answer the questions about this frigid moon on the outer edges of the solar system. Thank you everyone for watching this video. This is the first of the Solar System's Moons series. I have a lot of videos planned for this series and I can't wait to get working on them. I'm going to try and do as many as I can, try not to just focus on the really big moons as well. I'll try and get some videos out on some lesser known moons. I decided Triton would be a good place to start because it's one of my favourite moons. Thank you all for watching this video. I hope you all enjoyed and I'll see you all in the next one. Goodbye.